The last three problems on this study guide for Algebra B Test 3 Quarter 3 are word problems, and they're distance, rate, and time problems, and then a couple mixture problems as well. So let's take a look at the first one here. It talks about a car leaving an airport, drives due east at 60 kilometers an hour, and then 3 hours later an airplane leaves the same airport, flies the same direction, due east, at a much faster rate of 660 kilometers an hour, and how far from the airport will the car be overtaken by the plane, or when will the plane catch the car? And so we notice that asks how far from the airport. Far, that means they're asking for a distance. And so they want to know the distance from the airport will the car be when the plane catches it. And so that's important to understand what we're looking for. So let's go ahead and write down an equation here. We've got a plane and we've got a car. Two different items, and so we're going to write an equation for both of these using this as our basis for the formula, distance equals rate times by time. So what we're going to end up doing is, since they want to know how far from the airport the car will be, which will be the same as the plane, I'm going to go ahead and still use d for the car. The d represents the car's distance, and I'm going to use its rate, obviously, so 60 kilometers an hour. And then t for time, because we don't know the time. Now they do give us an expression that we're going to end up using for the distance. For the time, and we've got our own rate that we'll use for the airplane at 660. And its expression for time that I was talking about is from this part right here. It says 3 hours later. The airplane leaves the airport, the same airport. So I'm calling the car's time t. It's traveled a lot longer. It's traveled 3 hours longer. Since it's traveled 3 hours longer, but we don't know how long the plane's traveling or the car's traveling for. We just know that the car's 3 hours longer. Since the car's 3 hours longer, I'm going to use an expression for the plane, and the plane is going to be the t minus 3. So I'm going to take away 3 hours from the car's time because the car had been traveling longer than the plane. Now the distances will be equal because it asks how far from the airport will the car be when the plane catches it. Catches it means that it's going to be at the same place at the same time. So there we have it. We've got an expression for the time for the plane. We've got the distances being equal, different rates, so we're ready to solve. So what we're going to do is we're going to use the substitution method. We're going to take this expression, what the car is, its distance, 60 times by t, and we're going to put it in for d in the other equation. And so here's what we get. We get 60t equals, and then I'm going to go ahead and distribute this stuff right here. So 660t minus, and then I'm going to multiply the 660 by 3. So this ends up being 0, and then I get 18. And then another 18 plus 1 makes 19. So there it is, 1980. And then we can go ahead and do some opposite operations to isolate the variable. So I'll go ahead and subtract that 660t from both sides. And then from there, I'll do that subtraction, and I'm left with my 600, or negative 600t, equals, and then I've got the negative 1980. And so when you do the division, always remember this trick. If you got zeros at the end of each of the numbers, because I want to solve for t here, I'm dividing by 600, I can cancel these two zeros out. See, this 0 and this 0, basically it's like dividing by 10. So all I really need to do is this division, 60 into 198. And so when I do that division, I end up with t equals 3 3/10. And so from that point, I'm going to go ahead and I've got one more step. I need not to find the time, but the distance. And so remember, we want to know the distance here. That's the question. And so I need to substitute this 3.3 back into this t right here. And so I'm going to go ahead and do that work. d equals 60 multiplied by 3 3/10. So when I do that multiplication, I end up with 198 kilometers. And so there it is. Well, taking a look at the next problem, I've got a mixture problem. And whenever I have a mixture problem, this is the way I like to set these up. Now, in this class, we're not dealing with a lot of different types of mixture problems. They're pretty much the same type. And there are two main types that we dealt with, either an unknown amount of mixture or a known amount of mixture. And today's test, or this week's test, is going to be on an unknown amount of mixture. But we're going to end up with different types of rates, and we'll look at each of them as we go. So we have an amount of solution is my first part of the formula, and we're going to multiply by a rate. And for the mixture problems, you're always going to multiply that amount of solution by a rate. In this case, it's a percentage, and we end up with an amount of whatever the substance is, and that is salt in this case. So we go ahead and set up our equation. As we read it, it says how many gallons, right there. How many gallons? We don't know, so that's going to be X. How many gallons of a 70% solution must be mixed with? Again, we know that was the part because it says it must be mixed with. So we know we're going to mix this 70% with 40 gallons of a 23. So 40 gallons of a 23%. And then it says to make. So right there, that tells us now we're dealing with the mixture. And so I go ahead and put my mixtures on the bottom here. I'm going to put the 60% solution right here. And this mixture, the mix, means that we have to combine the two together. So when we combine numbers, we're adding them together. So it's going to be an X plus 40. So whenever you've got an expression in one of these little cells, you're going to put parentheses around it because you're going to have to use that distributive property. And we go ahead and do some work there. We get 70x equals, and then over on this side, we have a 920 when we multiply these two numbers. And then here I got to distribute this 60 over these two numbers, so I end up with a 60x, and this is plus 2,400. And then from there, it's the same as they always are. You're going to end up adding the top numbers in the two parts, and it's going to equal the mixture. And so here's what we end up with. We've got 70x plus 920 equals, and then I've got 60x plus 2400. And so from that point, I just do some opposite operations to isolate the variables. So I'm going to subtract that 920 from both sides. And I also need to subtract this 60x from both sides. And so this is a nice problem because we're going to end up with this 10x. And whenever you have 10x, it's easy to do the division. And so it all equals 1,480 when I do that subtraction. And so when we go ahead and do the division of 10, you see it's easy because it just moves that decimal over one space. Or in this case, we can just cross off these zeros, and so we're left with x equals 148. Now we look back at the type of units, and we're in gallons, so that would be our answer. So all it's asking for is how many gallons of the 70%. Well, x represented the amount of gallons of the 70%, because that's what our chart tells us. So you're going to see the same type of problem with this one here. It's going to be another unknown amount of mixture, so we don't know the amount of mixture. And so we're going to have an amount, but this time instead of a solution, it's going to be an amount of weight, and in pounds specifically, amount of pounds. And we're going to multiply by a rate, but this time the rate is different. It's going to be dollars per pound, we'll see. And then it's going to end up equaling an amount of money, an amount of cost. And that's what we're going to be looking at. And so we're going to end up with part 1 and part 2 and then the mix on the bottom. And so let's read off what we've got here. It says how many pounds of a candy selling for $1.80 per pound should be mixed with. So we know this is part of the mix. So how many pounds? We don't know. But we do know what the rate is. It's $1.80 per pound. And I'm just going to write 1.8 because the 0 at the end doesn't affect anything. And it should be mixed with 5 pounds, so 5 pounds of candy that sells for $2.80 per pound. And it should obtain. To obtain means we're dealing with the mix now. And so I know my mix comes last here, and to obtain a candy that sells for $2.30. So again, the two parts get added together to make the mix. Now, back to this problem here. I know I'm doing something right if the two rates of the parts are a small and a large. The mix should always be in the middle, because when you mix a large rate with a small rate, you get a mix that's somewhere in the middle. Also, we know which one it's closer to. If you look at the numbers, 2.8 is 5 away from 2.3, 0.5 away. And it is 0.5 away from 1.8, so it should be somewhere right in the middle. So let's see what we end up coming up with. My theory is that since it's right in the middle, it's going to be 5 pounds. Let's see if it works. And so when we go ahead and do the work, we multiply straight across. And so we're going to end up with 1.8x. Over here, we're going to multiply these two numbers. We end up with 14. And that's the same thing as 14.0, which you might end up getting. Here we have to distribute, so you got to be careful. Make sure you distribute both numbers. We end up with a 2.3x, and then on this side we end up with a, actually, since I'm in the decimal form, yeah, we're in that. So we have 11.5. And from there, again, it's just like what we had done before. So we go ahead and add the first two numbers together, it equals the last. And so we go ahead and do some work here. We've got 1 8/10 x plus 14 equals 2 3/10 x plus, change that sign there, plus, and this should be a plus sign as well here, plus 11 5/10. And so from that point, all we're doing is opposite operations. So we're going to bring that 11.5 back to the other side. Now, you got to be really careful on this one because you've got to end up borrowing. So I'm going to show you that step. And over here, since I need to move this 1.8x to the other side first, I'm going to go ahead and subtract that. So let's take a look at what we got here. So again, if you're doing this subtraction, you got to make sure you end up borrowing from that 4, change it to a 3, and we're left with a 2.5. Over on this other side, when you do that subtraction, we're left with 0.5x. And so when we do division with decimals, what I do right now is, since I can't divide by decimals, I move that decimal over. It makes the division a little bit easier when you don't have to deal with it. And so now I'm just going to divide by 5 on both sides, and I end up with 5, which is what we thought it would be because the amount of mix was right in between the two parts. And so it makes sense for it to be exactly 5 pounds and the other amount being 5 pounds. So those are the types of problems you'll end up seeing on the test. Good luck.